This is lesson 3-6, equations and problem solving. Most of this lesson deals with lots and lots of word problems, and I'm going to show you various different methods on how to solve them. It's very important that you understand the vocabulary behind them, so make sure you take careful time to digest the vocabulary as we go through it. Consecutive integers are integers that follow each other when counting by ones. For example, 12, 13, 14. Those are consecutive in a row. Consecutive even integers. When you think about it, if I gave you 3 consecutive even integers like 22, 24, and 26, you'll notice they're always 2 numbers apart. So consecutive even integers, 2 numbers apart. 22, 24, 26, 58, 60, 62, 142, 144, 146, etc. Consecutive odd integers are numbers that follow each other when counting by 2s and starting with an odd number. So if I start with an odd number like, say 7, I would have 7, I would have 9, and then I would have 11. You'll notice you also are skipping 2. You're counting by 2s. Okay, 7 plus 2 is 9, 9 plus 2 is 11, 11 plus 2 would be 13. So consecutive even integers and consecutive odd integers are always 2 numbers apart. The difference is in consecutive even integers, you start with an even number, and in consecutive odd numbers, you start with an odd number. Uniform motion is an object that moves at a constant rate. It's based on the formula that distance equals rate times time. And many of you have seen that in your science classes before, and I know we've dealt with it a little bit with math. We'll get into the more details of it when we get to some later example problems. Okay, let's take a look at some things. Some problems contain 2 or more unknown quantities. When this happens, you must first decide which unknown quantity the variable will represent. Once you figure out what everything's being compared to, then you can express the other unknown quantities in terms of that variable. Let's just look at a couple of examples to get us started. We're going to write some expressions. Remember, algebraic expressions do not have equal signs. So we'll start off with some algebraic expressions. Twice a number n. This could be written as 2n, twice a number n. Half the number n. Now this can be written a couple of different ways. This could be written as n divided by 2, because that's half. It could be written as 1/2 times n, because that's half. Or, last but not least, you can decide to write it as 0.5n, because that is also half. Any of those 3 things are acceptable, depending upon how you want to write it. It doesn't really matter. 5 more than a number n. Again, more than means that n comes first. So n plus 5. 5 more than a number n. This week, Belinda worked 3 more than twice as many hours as last week. Okay, so notice this week is being compared to last week. So we're going to let n be the number of hours worked last week. And we're going to write an expression based upon that. Since this week is being compared to last week, and n has to be last week. So if n is last week, this week she worked 3 more than twice as many hours as last week. 3 more than twice as many hours as last week. Last week's hours was 2n, that's last week. Twice last week would be 2n, and then 3 more than that is 2n plus 3. Number 5 here. The depth of the new well is 4 feet less than 3 times the depth of the old well. Let W be the depth of the old well, because the new well is being compared to the old well. The old well becomes our variable. Alright, so W equals the old well. And if we look up here, the new well is 4 feet less than 3 times the depth of the old well. Okay, so let's look at some of this stuff. We want 4 feet less than, 4 feet less than 3 times the depth of the old well. Okay, so the old well was W, so 3 times that would be 3W. So 4 feet less than 3 times the depth of the old well. So 3W minus 4 becomes that expression. Now we're going to write some expressions for consecutive odd and even integers. says write an expression for the sum of two consecutive integers. They're not odd and they're not even, which means they're in a row. And numbers that are in a row, like 2, 3, 4, are only one number apart. So if I let n equal my first integer, my next integer would be n plus 1 because it's going to be 1 higher. And you notice 3 is 1 more than 2. 4 is 1 more than 3. So whatever our integer is, if we start with n, the next integer has to be n plus 1. That will be my second integer. So first you define your variables. That's very, very important. If you don't define your variables in your homework, I will mark them wrong. You must define your variables because that helps set up everything else. So now I need to write an expression for the sum of those two. Sum means add them together. So it becomes n plus 1. And that's the expression for the sum of two consecutive integers. Number 7, write an expression for the sum of two consecutive even integers. Okay, so again, we have to start with a variable. I'm going to let n equal my first even. Now, I'm not going to say first integer, but I'm going to make it first even integer because you have to start with an even number. If you remember what I said earlier, if you start with an even number, to keep it even, you have to keep adding 2. If I start with 4, to keep it even, I have to add 2 to get 6. 4 is even, and 6 is even, and it's the next consecutive. So if n is my first even, n plus 2 is my second even integer. And the sum of them would be n plus 2. Excuse me. Let's look at number 8. Write an expression for the sum of 3 consecutive odd integers. Okay, odd integers now. So I'm going to let n equal my first odd. To keep them odd, you're not going to add 1 or 3. You're still adding 2. Because if I have the number 7, to get to 9, I have to add 2. And to get to 11, I have to add 2. So odd numbers are 2 numbers apart, just like even numbers are 2 numbers apart, as long as you start with an odd or start with an even. So n plus 2 will be my second odd. And since I have 3 of these this time, n plus not 2, but 2 more than 2, n plus 4 would be my third odd. So that expression for the sum again, which is adding, so it would be n plus 2 plus n plus 4. And if you like, you can put them in parentheses. It's not going to change the answer in any way, shape, or form. It just makes it easier to see. That's the first number, this is the second number, and this is the third number. Okay, we're going to write an equation to solve. Arthur is 2 years younger than Chan. Arthur is 21. How old is Chan? You're probably looking at me going, I can answer this without having to write an equation. True, you probably can. I'm hoping you can. If you can't, we're in trouble. However, if you can't write a simple equation for the easy ones, you will not be able to write a simple equation for the more difficult ones. So I want you to practice doing the easy ones just as you would the difficult ones. Okay, Arthur is 2 years younger than Chan. Everything's being compared to Chan, so I'm going to let C equal Chan. That also tells me how old is Chan. Okay, that's what the variable's asking, so I'm going to let C equal Chan's age. Okay. Arthur is being compared to Chan. Okay, so Arthur is 21. Arthur is 21. Arthur is 2 years younger than Chan. Right here it says Arthur is 2 years younger than Chan. So Arthur's age, 21, is 2 years younger than Chan. So Chan's age minus 2 gives us Arthur's age, doesn't it? So Chan's age minus 2 gives us Arthur's age. So to solve for Chan, we just add 2 to both sides. 23 equals C. So Chan is 23 years old. And I'm sure you could have solved this without writing the equation. However, you would have lost a lot of points because you get a point for defining your variable, you get a point for writing your equation, and you get a point for your solution. So you would have only gotten 1 out of 3 points, or 33% of that problem correct had you not written an equation and done all the other work. All right, let's take a look at this next problem. The number of salted peanuts in a nut mix is 13 times the number of cashews. Wow, I spelled cashews wrong. Ignore the H. There are 52 peanuts. How many cashews are there? Okay, notice it's asking us how many cashews. And the number of peanuts is being compared to the number of cashews. Look at this, hold on. So, since everything's being compared to cashews, I'm going to let a variable equal cashews. I'm going to let C equal number of cashews. That's what I'm supposed to find. And that's what it's being compared to. So, the number of salted peanuts in a nut mix is, the word is in English means equals. He is cold means he equals cold. Same thing happens in math. The number of salted peanuts in a nut mix is 13 times the number of cashews. And it says there are, and are is another form of the verb is. So there are 52 peanuts. So 52 peanuts, the number of salted peanuts in a nut mix, is 13 times the number of cashews. That's my variable C. So 15 equals, let's see, 52 equals 13C. Now all I need to do is solve this. Okay. So I can say, okay, so I divide by 13. 52 divided by 13 is 4. So C equals 4. I'm supposed to solve for how many cashews there are. I have done that, so there are 4 cashews. Let's do a couple more here. These get a bit more complicated, so make sure you're paying attention. A rectangular garden is 40 feet longer than it is wide. The total length of the fence that surrounds the garden is 1,000 feet. How wide is the garden? Now, most of you like to use length and width, but length and width can get a little hairy because lengths look like ones. So I'm just going to use X and Y because it makes it a little bit easier. Or I can just use W and compare everything to W. The easiest thing to do to start with is this draw a rectangular garden. Pictures are helpful. It says a rectangular garden is 40 feet longer than it is wide. Notice its length is being compared to its width. And it tells us the total length that surrounds the garden is 1,000 feet. That's our perimeter. That's all the way around. And it's asking us to figure out how wide is my garden. So obviously, one of my variables has to be W. I'm going to let W equal the width of my garden. Now notice my length is 40 feet longer than it is wide. So W plus 40, my width plus 40, has to equal my length. So here I've got this is W and this is W plus 40. When we talk about a perimeter, we're talking about all the way around. In other words, 2 widths plus 2 lengths equals perimeter. Okay? So 2 widths, 2 times W, plus 2 lengths, 2 times W plus 40, equals my perimeter, which is 1,000. 2 lengths plus 2 widths equals my entire perimeter. Now I'm simply going to simplify this problem. So this becomes 2W plus, if I distribute, make sure you distribute properly, 2W plus 80 equals 1,000. So 2W plus 2W is 4W plus 80 equals 1,000. Subtract 80. 4W equals 920. Take 920 and divide it by 40, and you're going to get 23. 920 divided by 4, you're going to get 230. I divided by 40, I don't know why. So you're going to get 230. So my width is 230 feet. That's what it asked me to find. If I wanted to find my length, all I would have to do is substitute in 230 in for W here, and I can find my length. Since it only asked me to find how wide my garden is 230 feet wide. done. So a couple more problems here, and we'll be done with part 1. The sum of an integer and twice the next consecutive integer is 29. What are the integers? Okay, twice the next consecutive, not even or odd. So I'm just going to let n equal my first integer. Okay, and n plus 1 is my second integer. There we go, let's start, right? It says the sum of an integer, n, and twice the next consecutive, 2 times the next consecutive is n plus 1. It needs to be in parentheses, otherwise when we multiply it by 2, we're not going to multiply all parts of it by 2, is equal to 29. We just simply read directly off of this. Sum means add of my integer, and twice the next consecutive integer is 29. So now we can simplify. N plus 2n plus 2, because we should distribute this, equals 29. So n plus 2n is 3n. 3n plus 2 equals 29. Subtract 2. Move this up over here so you can see it a little better. So we have 3n equals 29 minus 2 is 27. Divide by 3, n equals 9. So what are the integers? The first integer is 9, and the second integer is 9 plus 1. So n plus 1 would equal 10. So my integers are 9 and 10. I know this is a lot of examples, but I want to make sure that we get through lots and lots of examples so that you are not confused. The sum of 3 consecutive integers is 72. 3 consecutive, not even or odd. So n equals my first, n plus 1 equals my second, n plus 2 equals my third. Excuse me. So sum means add them together. So n plus 1 plus n plus 2 is 72. Simple as that. Now we just simply combine. N plus n is 3n. 1 and 2 is 3. So 3n plus 3 equals 72. Subtract 3 from both sides. 3n equals 69. Divide by 3. N equals 23. So n equals 23, n plus 1, n equals 23, n plus 1 would equal 24, and n plus 2 would equal 25. So my integers are 23, 24, and 25. Always answer in a complete sentence. Alright, this next problem. I'm glad you didn't have to type these out yourself. The sum of 3 consecutive odd integers is 117. So now we have odd integers. So I'm going to let n equal my first odd. I have to label it as first odd. Odd integers, if you remember to keep them odd, you have to keep adding 2. So n plus 2 equals my second odd. I have 3 of these guys, so n plus not 2 but 4 equals my third odd. If I had a fourth odd, it would be n plus 6 and n plus 8, etc., etc. The sum of 3 consecutive odd integers is 117. First odd integer plus second odd integer plus third odd integer is 117. Now we simply simplify. N plus n plus n is 3n. 2 and 4 is 6. Equals 117. Subtract 6. 3n equals 111. Divide by 3. 111 divided by 3 is 37. So n equals 37. N plus 2 is 37 plus 2, which is 39. N plus 4 is 37 plus 4. which is 41. And my three integers are 37, 39, and 41.